Hi guys! We are going to continue our second video talking more about parallel and perpendicular lines. In our first video, I gave you two lines and I asked you to compare them and figure out, are they parallel, are they perpendicular, or are they neither? In this video, I'm going to give you one line and your job will be to find the second line that is either parallel or perpendicular, depending on the directions, to the first line. So I'm giving you one and you need to find the second one. Don't forget to pause the video so that you can write down the problem. In this question, I'm asking you to get me an equation in slope-intercept form. And I want that equation to represent a line that goes through the point 3, 1, and that is parallel to the line that you get when you graph 3x plus 2y equals 1. Let's take a look at what that looks like conceptually. So in this problem, I was given an ordered pair, 3, 1, which would be right here. And I was given a linear equation. Now tomorrow we will learn how to graph a linear equation. But for right now, let's just pretend like this is the graph. So I've given you a point and a line. Our job is to figure out the equation of a second line that touches this dot and is parallel to the first line. And we want that line to be in slope-intercept form. Okay, so that's what we're going to do. Now, we're not going to do it graphically because this is not necessarily going to be perfect. And so we're going to do it using algebra. To start with, if I want the line to be parallel, I need to know the slope because the definition of parallel lines is lines with the same slope. So first, let's find the slope of the equation that they gave us, the 3x plus 2y equals 1. As mentioned in the first video, this is in standard form. And so we need to change it to a form where we can actually find the slope, which would be slope-intercept form. I can do that by subtracting the 3x and dividing everything by 2. And now I know the slope of my first line, my given line, is negative 3 over 2. Using that information, I can now write my equation of my second line, the one that was not given to us. This will be a brand new equation. You will not be using the equation that they gave us. You're not even going to look at it. The only reason why we need this equation is to get the slope. So I will be using the slope, which we just discovered was negative 3 over 2, to write a line parallel. So I want to use the same slope so that they have identical slopes. And then the other piece of information that I'll be using is I'll be using this point 3, 1. So I'm using the same slope as the original equation and this ordered pair, and I'm going to write a brand new equation. I'll be using the method that I taught you in class, which is to take our slope formula and plug it in and do some cross multiplying. Here's my slope formula. We're plugging it in and we're cross multiplying. We talked about how you want to always write the letter y on the left side and the letter x on the right side because that will get us closer to what our answer should be. Make sure that you're distributing. I'm going to add my constant from the left side to the right side. And finally, I will divide everything by 2. And this is my final answer. This is the equation of my red line, a line that is definitely parallel to the black line and that goes through this point that they gave us. Notice that it is different than my equation over here. They have the same slope because they're supposed to, but they have different y-intercepts. So I definitely know these are different equations. Okay, let's take a look at one more example. In this example, we'll be writing a line that's perpendicular. Okay, so kind of the same concept, kind of the same starting point. There's going to be one little twist in the middle to draw a perpendicular line. So just like on the last problem, I want to find an equation in slope-intercept form of a line that goes through the point 2, -1. So let's go ahead and draw that on our graph, 2, -1. And I want that line to be perpendicular to the line that we get when we graph x minus 4y equals 16. So I'm going to just sketch out, the graph is going to look something like this. Okay, so this is the line that was given to us, and this is the point that was given to us. And again, our job is to find a second line that touches this dot and is perpendicular to the black line. And that line I want written, again, in y equals mx plus b form. Now, again, I just sketched this out. This is not perfect. I can't look at my red line that I drew and say, oh, it's this and it's that. No, this is a sketch. So we're going to use some algebra to find that equation. To help us out, the definition of perpendicular lines are two lines whose slopes are opposites and also reciprocals. And so to make sure that my two lines are going to be perpendicular, I need to first find the slope of the existing line that they gave us, the x minus 4y equals 16. This, once again, in standard form, so I'm going to need to change it to slope-intercept by subtracting the x and dividing everything by -4. And so now I know that my slope of the original line, this line, is positive 1/4. Now here's where the twist comes in. So I need to write now a brand new equation for my red line. But this time I want my equation to be perpendicular. So on our first example, we wanted parallel lines, which meant that the slopes had to be exactly the same. When we want perpendicular lines, we do not want the same slope. We want an opposite and reciprocal slope. Opposite means that the signs are different, and reciprocal means we flip it upside down. So knowing that my slope is positive 1/4, the opposite and reciprocal would be -4/1. So that's the twist. That's the only thing that changes between parallel lines and perpendicular lines is you have to change your slope for a perpendicular line. And you have to do it before you start writing the equation. So you cannot write the equation and then change it at the end. It has to be something that you do before you even start writing that second equation. We're also going to use the ordered pair. And we're going to do something, again, very similar to our first example and all of our work yesterday. So I'm going to use the slope formula. I'm going to plug in my slope and my x1 and my y1. I'm going to cross multiply. I'm going to make sure that the y gets written first and the x gets written second. I'm also going to make sure that I'm distributing. Please note, I put the negative sign on top with the number 4. I attached the negative sign to the top number. You should always attach the negative sign to one of the numbers. Don't have it floating up in front. Attach it to a number. And then on this one, I'm almost done. I'm going to minus my 1 on both sides. And this is my final answer. This is an equation in slope-intercept form that is perpendicular to this equation. They have opposite and reciprocal slopes. This concludes our second video. Your homework tonight is a worksheet.